Okay, I'm not going to go through truth tables for the logic gates we've looked at, which is OR, AND, and NOT. But what I am going to do is talk about XOR, NAND, and NOR. But before we talk about any of those, what you see in front of you right now are the symbols for the different logic gates. Your job is to remember them and to be able to draw them accurately. Now, these symbols can be combined together to create circuits, but we're not going to look at that now. Let's just look at each individual logic gate. So let's look at XOR. This is relatively easy. If an input 0 and B 0, oops, I put X, it should be Q. Let's change this. Q will be 0. Simple. If I did A as being 1 and Q as being 0, the output is going to be 1. If I did this is 0, this is 1, the output is going to be 1. If I did this is 1, this is 1, the output is going to be 0. So the output is going to be 1 if our inputs are an odd number. So in this case, because A is 1 and B is 0, if you add 1 and 0 together, it's going to be 1. So the output is going to be 1. Same with this. As we've got two ones, it's an even number, so the output is going to be 0. So that is the XOR. Now let's have a look at a NOR gate. So let me just change our view. Okay. Pause. Okay, so if we had 0 or 0, normally on an OR gate that would be 0, but in this case, notice we've got a NOT here. And what does a NOT do? Yes, it reverses it. So 0 and 0 would actually equal 1. Let's imagine that this was a 1 and this is a 0. 1, 0. Now in an OR gate, this would be 1 because 1 or 0 and it will output 1. But because it's a NOT gate, it will be 0. Same way the other way around. Now if we had 1 or 1, on an OR gate, it will still be 1, but because of this NOT, it will reverse it to be a 0. With a NAND, it works very, very similar. It's an AND gate, but because we've got a NOT in it, so the N stands for NOT, it reverses the outcome. So normally, if 0 and 0 are the same, it will equal 0. But in this case, because we've got a NOT, it reverses it to 1. If we had this being 1 and this being 0 on an AND gate, the output would be a 0. But in this case, because we've got the NOT, it reverses it. So it's not going to be 0, it's going to be 1. Same with this. If this is a 0, this is a 1. Normally it'll be a 0 because they both have to be 1. But because it's a NOT gate, it's going to reverse it. And here, if it's a 1 and a 1, normally it's going to be a 1. That would be what an AND gate would be. But because we've got the NOT, it reverses it. And there you go.